Every time you step out of a sweltering summer street into a perfectly chilled grocery store or office building, you are living inside a machine designed by one man. You do not just feel the cold air on your skin, you are experiencing the hidden architecture of modern human existence. That invisible architecture was built by Willis Carrier, a mechanical engineer who fundamentally altered human geography. Carrier is the man who conquered the weather and secretly decided the temperature of your life. Before his intervention, the local climate dictated exactly where humanity could build, work, and thrive. For thousands of years, civilizations fought extreme heat with passive, architectural defenses. Ancient builders designed homes with thick stone walls, shaded interior courtyards, and tall windcatchers to capture passing breezes. Wealthy elites imported massive blocks of ice harvested from frozen northern lakes during the bitter winter months. In the late 19th century, hospitals and theaters tried blowing air over these massive blocks of melting ice to cool their patrons. This primitive cooling method was incredibly expensive and left the enclosed rooms smelling like a damp, rotting basement. It only increased the indoor humidity, making the oppressive summer heat feel dramatically worse. No one had ever figured out how to manufacture stable, dry weather on demand inside a closed room. The indoor industrial environment was completely at the mercy of the unpredictable outdoor seasons. Manufacturing sectors that relied on precise, stable atmospheric conditions faced crippling financial losses every single summer. Willis Carrier was born in 1876 on a modest farm in western New York. He was a quiet, highly analytical child who struggled with basic fractions during his early education. His mother finally taught him to cut whole apples into smaller physical pieces to visualize and conquer the math. This early lesson in breaking complex problems into physical, measurable parts defined his entire engineering mindset. After graduating from Cornell University in 1901, Carrier took an entry-level job at the Buffalo Forge Company. He was initially tasked with designing heavy industrial heating systems to dry wet lumber and roasted coffee beans. His true historical test arrived just 1 year later, during the sweltering summer of 1902. A frustrated commercial client in Brooklyn, called the Sackett-Wilhelms Lithographing and Publishing Company, was facing a catastrophic production crisis. The brutal summer humidity rolling off the New York harbor was causing their porous printing paper to absorb moisture and expand. As the paper warped and shifted, the 4 separate colors of printing ink failed to align perfectly on the page. This microscopic shifting ruined entire production runs of expensive, high-quality color magazines. The Brooklyn printers were desperate enough to try anything to save their lucrative publishing contracts. They had already tried opening all the factory windows and running massive industrial exhaust fans. Nothing stopped the paper margins from shifting by disastrous fractions of an inch on the printing press. The printing executives begged the engineers at Buffalo Forge for a permanent mechanical solution to their persistent humidity problem. Carrier realized immediately that controlling the ambient room temperature alone was not enough to save the colored ink. He had to invent an entirely new machine to pull the invisible moisture straight out of the factory air. Legend claims Carrier solved the puzzle while staring at the thick fog rolling off a train platform in Pittsburgh. He observed that natural fog was simply atmospheric air completely saturated with liquid water vapor. He reasoned that if he could artificially create fog inside a machine, he could dictate the exact amount of moisture the air could hold. The young engineer sat down and drafted a revolutionary schematic on a single piece of heavy tracing paper. His blueprint detailed a closed system that forced humid factory air across metal coils filled with naturally cold artesian water. As the warm air cooled, its heavy moisture condensed into liquid droplets and dripped away safely into a pan. The remaining air pumped back into the factory was both perfectly chilled and completely dry. The Brooklyn printing presses finally operated at exactly 55% humidity. The 4 colored inks aligned perfectly on the page, regardless of the chaotic harbor weather outside. Carrier had not just cooled the room, He had invented modern air conditioning by actively stripping the moisture from the air. To replicate this success, the young engineer needed to map the invisible relationship between heat and humidity. In 1911, he presented his rational psychrometric formulae to the American Society of Mechanical Engineers. His dense, mathematically complex chart allowed any architect to precisely calculate the dew point required to pull moisture from any industrial room. Recognizing the massive commercial potential, Carrier and 6 colleagues pooled $32,000 in 1915. They formed the Carrier Engineering Corporation to sell standardized weather to the highest bidder. Their early clients were entirely focused on protecting fragile materials, not providing comfort for human workers. Textile mills in the blistering American South purchased the massive machines to prevent delicate cotton threads from snapping. Munitions factories during the First World War installed the technology to keep explosive black powder perfectly dry. In these harsh industrial spaces, human laborers simply had to endure whatever atmospheric conditions the raw materials required. Cooling large public spaces for human comfort remained incredibly dangerous for several more years. Early industrial cooling systems relied on highly toxic and flammable refrigerants like ammonia to chill the heavy coils. A single ruptured pipe inside a crowded theater or hospital could instantly poison hundreds of innocent people. Carrier knew he had to completely redesign the mechanical chilling process to make it safe for public architecture. In 1922, his engineers unveiled the first centrifugal refrigeration machine inside their Newark factory. The massive barrel-shaped compressor safely utilized a non-toxic liquid coolant, spinning it at high speeds to reliably generate huge volumes of chilled water. This safe, compact centrifugal chiller finally allowed engineers to target the most lucrative audience in America. During the 1920s, grand movie palaces routinely shut down during the summer because human body heat turned crowded theaters into suffocating ovens. Hollywood executives desperately needed a way to keep their cash registers ringing through July and August. The ultimate test came on Memorial Day weekend in 1925 at the Rivoli Theater in Times Square. Carrier personally oversaw the installation of a massive cooling system hidden behind the theater's ornate plaster walls. The marquee outside prominently advertised a revolutionary new feature to the sweltering public: refrigerated air. Curious patrons poured into the lobby, nervously anticipating a harsh blast of freezing winter wind. Instead, they experienced a perfectly controlled, comfortably dry atmosphere that felt like a crisp autumn afternoon. The summer blockbuster was officially born, fundamentally shifting the economic calendar of the global entertainment industry. Following the massive financial success at the Rivoli, institutional power brokers began demanding their own private climates. By 1929, Carrier systems were actively cooling the chambers of the United States Senate and the House of Representatives. American politicians were suddenly insulated from the oppressive Washington summers that had historically driven them out of the Capitol. Soon, elite corporate executives realized that a cooled office building provided a massive competitive advantage. They no longer had to send their clerical staff home early during the frequent metropolitan heat waves. Productivity and towering skyscrapers soared, cementing air conditioning as an indispensable tool for corporate efficiency. Despite these massive commercial victories, the technology remained far too bulky and expensive for the average family home. For the next 2 decades, Carrier's invisible architecture was exclusively reserved for wealthy business owners and powerful politicians. The average American still spent their summer nights sleeping on fire escapes and front porches to survive the brutal heat. The true turning point for human geography arrived immediately after the conclusion of the Second World War. Millions of returning soldiers demanded cheap, modern housing in the rapidly expanding American suburbs. Carrier recognized that to truly conquer the global climate, his massive industrial chillers had to be drastically miniaturized for the everyday consumer. The solution was the self-contained window air conditioning unit, a heavy metal box designed to sit directly on a residential windowsill. Inside this compact steel casing, a motorized compressor forcefully squeezed a chemical refrigerant gas until it became a scorching hot liquid. The hot liquid was pumped to the outdoor half of the unit to physically release its captured heat into the summer sky. Simultaneously, the pressurized liquid passed through a tiny expansion valve into the indoor half of the window unit. As the liquid rapidly expanded back into a gas, it absorbed massive amounts of heat, turning the copper indoor coils freezing cold. A small electric fan then blew the warm room air directly across these frosted indoor cooling coils. As the room air chilled against the copper, it lost its capacity to hold water vapor. The resulting condensation dripped harmlessly out the back of the metal chassis and onto the sweltering sidewalk below. By 1951, inexpensive window units utilizing this exact cycle were finally rolling off assembly lines and into middle-class living rooms. The initial marketing of these residential machines heavily targeted the exhausted American housewife. Glossy magazine advertisements promised that an artificially cooled home would prevent summer fatigue and keep children perfectly behaved during August heat waves. The ability to afford this manufactured indoor weather quickly became a powerful new status symbol for the post-war middle class. The mass production of artificial residential cold triggered the largest internal human migration in American history. Before Carrier's invention, the blistering, oppressive heat of the American Sun Belt made large-scale industrial urbanization almost impossible. Now vast desert landscapes and humid coastal swamps were suddenly open for massive real estate development and corporate relocation. Entire modern metropolises like Phoenix, Houston, and Miami exploded in population during the 1960s and 1970s. Sprawling retirement communities sprouted across Florida, populated entirely by northern seniors who could finally survive the grueling southern summers. The political and economic center of gravity in the United States permanently shifted southward, entirely subsidized by mechanical cooling. But this sudden technological mastery over nature came with severe, permanent cultural and architectural consequences. Traditional building designs that passively worked with the local climate were immediately abandoned by cost-cutting residential developers. High-rise apartment buildings and suburban tract homes were suddenly constructed with sealed glass windows and low ceilings, rendering them completely incapable of natural ventilation. The deep, shaded front porches where neighbors once gathered to escape the stagnant evening heat vanished from modern residential blueprints. Society retreated indoors behind locked doors and permanently closed windows, trading daily community interaction for isolated thermal comfort. Humanity had effectively sealed itself inside a refrigerated plastic and glass box, entirely dependent on a fragile, invisible electrical grid. This architectural shift quickly spread beyond the borders of the United States to transform the entire developing world. Soaring glass skyscrapers that would naturally act as deadly greenhouses were suddenly erected in tropical megacities from Dubai to Singapore. International commerce standardized around the Western business suit, an outfit only tolerable in the tropics because of Willis Carrier's artificial indoor winter. Without Carrier's invention, the modern digital economy would also immediately grind to a catastrophic halt. The massive hyperscale server farms that power the global internet generate temperatures hot enough to literally melt their own silicon processors. These crucial data centers require continuous, industrial-scale refrigeration systems that operate on the exact same thermodynamic principles Carrier drafted in Brooklyn. This artificial dependency created a terrifying environmental paradox that haunts our modern infrastructure today. The early chemical refrigerants used to chill these millions of homes silently tore a massive hole in the Earth's protective atmospheric ozone layer. Even today, the colossal amount of electricity required to power global air conditioning actively accelerates the warming of the outside atmosphere. We are caught in a vicious, escalating feedback loop designed over a century ago by a man trying to dry printing paper. As the outdoor climate grows increasingly hostile, our absolute reliance on mechanical survival boxes becomes an existential necessity. We have built trillions of dollars of global real estate in uninhabitable deserts that would become deadly without constant artificial cooling. Willis Carrier died in 1950, just as his invention was beginning to reshape the entire globe. He started with a math problem about wet ink and ended up dictating the architectural boundaries of modern human civilization. Looking at the fragile power grids of today, do you believe our absolute reliance on artificial climate control is a technological triumph or a dangerous trap? Understanding the hidden systems that dictate our daily lives gives you the power to see the world as it truly is. To uncover more secret histories and the invisible architecture of our modern institutions, subscribe to our channel.